Hi, in this video we're going to talk about how to do Punnett squares that are called sex-linked. The genes located on the X and Y chromosomes show a pattern of inheritance called sex-linked. A sex-linked gene is a gene located on a sex chromosome. You might have remembered earlier that Y chromosomes are only found in males, and they are only passed on from fathers to sons. Genes located on the X chromosomes are found in both sexes, but the fact that men have just one X chromosome leads to some interesting consequences. Now, a couple things just to kind of remind you, we have 46 total chromosomes in a diploid cell. 44 of them are called autosomes, and then the other 2 are called sex chromosomes. And again, this is where females have XX and males have XY. And so all we're talking about are the chromosomes that are going to be found on these particular chromosomes. And because the XX combo makes you a female, you'll need two versions of that copy. But for males, this is going to be the one time only where whatever gene is on that X chromosome, that's what's going to show, because they only have one version. So humans are going to have 3 genes that are going to be responsible for how you see color. They are all located on the X chromosome. In males, a defective allele for any of these genes results in color blindness and inability to distinguish certain colors. The most common form, red-green color blindness, occurs in about 1 in 12 males. Among females, however, color blindness affects only about 1 in 200. In order for a recessive allele, like color blindness, to be expressed in females, you must have 2 copies, 1 on each of those X chromosomes. The recessive phenotype of a sex-linked genetic disorder tends to be much more common among males than among females. Here's the numbers, so it's much more common among the males because they only have the one version. So now that we know a little bit about sex-linked, we're going to go through and do a practice problem, because these are going to be a little bit different. One, we have to first figure out the moms and the dads. So we're going to show moms by doing XX, and we have to show dads with the XY. And then the way I think it's the easiest way to do it is just to have a plain old X if you have a dominant trait. And if you are looking at a recessive disorder like color blindness, I don't like to use C's, so we'll just use lowercase b's. And if you are a carrier, so here females can be carriers. So this dominant X that has nothing attached to it is going to be a normal X. It would have like the dominant big B attached. Okay, so some people write that in there. They show the big B. That's up to you if you want to do that or not. But if you have a little b, it means that you carry the recessive allele for color blindness. For guys, they cannot be carriers. It's either on the X or it's not. So if we had just XY, we would assume that he has the big B, like the normal ability to see color. However, if he is colorblind, then that's where we would write in the little b, and that would mean that he is colorblind. On his X chromosome, he carries the gene for colorblindness. So let's put these two guys together, guys and girls. So we're just going to have our mom here being the carrier, and then the dad, and again we fill in. Now, genotypes, again, are easy because all we need to do is just write what's in each of the boxes, okay? If any of them are the same, then, we could combine boxes together, but these look like they're all different, so we just write it out. When it comes to phenotypes, it gets a little tricky in terms of you just have to know what they're asking. Like if if the question asks, or they're describing in the question, this couple like just had a baby and they're holding their baby girl in their hands, like they know that they have a girl. But what are the chances that the girl that they're holding is colorblind? Well, then you would just look at the boxes that are for the girls, and you would say, well, of these two boxes, there's a 50% chance that that baby girl is going to be colorblind because she would contain two little B's, and so for girls, it's the same thing, just like any other recessive disorder. You have to have two versions of it in order to show it. Where this girl, she's a carrier, so she's carrying the recessive allele, but this first X that has nothing attached to it means that she has just a normal dominant, can see color fine allele. If the question, however, says, this man and woman want to, they're going to get married, they're going to have kids, so what's the chance of their baby, whatever, being colorblind or not colorblind? Well, then you got to start talking about, you have to answer in terms of boys and girls and whether they're colorblind or not. So your answer in that case, that's what we're going to write out here. You would have a 1/4 chance of having a girl who's a carrier. That's in that first box. This one right here. There'd be a 1/4 chance of having a girl who is colorblind. There's a 1/4 chance of having a normal boy. And there's a 1/4 chance of having a boy who is colorblind. Okay, so this boy right here, he's a boy because he has the X and he has the Y, but because of that little B there, I'm not showing that he is colorblind. This one, he's got a normal X, a normal Y, so he's just a boy. So notice the phenotype we're giving, we're saying whether they're boys and girls, and then we're saying, if they're carriers or if they're actually colorblind or not. If they just want to know what's the chance of a kid being colorblind, colorblind, there's a 50% chance that whatever kid they have, it'll be colorblind. But you cannot go wrong if you write girls and boys, and then on top of that, go through and explain whether they have the disorder or not. All right. So I hope that helps. This is just one example of how sex-linked inheritance is going to work. Again, if you know it's sex-linked and in the problem it starts talking about, this disorder is located on the X chromosome, then you have to write your X's and your Y's and then put your little superscript with the letter. Okay, so that's going to be a big difference, and I'll mark it wrong if you just, if you give me a Punnett square without the X's. So if you just do B's, and little B's, that'll be marked wrong. Okay? All right, so again, hope that helps. If you have any questions, feel free to ask. Have a great day. Jesus loves you.